explain these graphs for the last lab?
Okay. We've talked about some of the math definitions of these things, such as acceleration is the change in velocity over the change in time, and velocity is the change in position over the change in time. So we'll just concentrate on those for just a moment. Flashback to math class. What is slope?
How steep, right? How steep,
Okay, conceptually, how would you find slope?
Rise over run,
Okay,
y equals mx plus b, where n would be the slope.
all right. I don't use m for slope because we use m for mass, we use m for meters, we use them way too often, so I just use a dollar sign for slope.
Gotcha.
So you were talking about y equals dollar sign x plus b form. The number in front of the x is the slope. So if I have a graph of position versus time, and it looks like that. Well, if I take 2 points on here, and I look at this value, which would be a change in x, and I look at this value, which is a change in time, and I do rise divided by run, what will that tell us? Okay, or in terms of physics,
The velocity.
yes. So the slope of my position time is velocity. So if my position graph goes like that, so if this is position versus time, is this a positive slope or a negative slope?
Positive.
It is indeed positive. That's a positive slope. So my velocity is positive. If it's doing that, my velocity,
Is negative.
yes. Similarly, if I'm looking at acceleration, or if I have my velocity versus time graph, acceleration is the slope of this. But my rise would be changing velocity, my run would be changing time. So that would be positive acceleration, negative acceleration,
0.
yes. And over here,
Negative.
that's supposed to be a flat line.
0.
Zero what?
Velocity.
I think someone just said it.
Zero velocity?
Yes, zero velocity, because this is position
Oh.
time.
Looking at the wrong one.
So in that last section, if you can get one of them, potentially you can just work out the others, especially if you have position versus time. We'll come back to this. So if I have a position versus time graph like this, I know that my slope is constant, so therefore my velocity is constant. I know that it's a positive slope, so my velocity versus time graph is some positive number, and it's constant. The slope of this is acceleration versus time. Well, what is that slope?
The acceleration would be 0.
Yes, the acceleration is 0. All right, that's the basics there. Next step, let's make it more complicated. You know what, we'll just start over here. Apparently, I guess I'm clearing everything off. Now, if you perform this, that would kill you. We'll look at the way it will kill you in just a moment. All right, so up till here, up to this time right here, what can you tell me about the velocity?
It was positive constant velocity, and then it switched direction while the velocity became negative.
All right, so,
Positive velocity at this point.
okay, positive, constant, up to whatever time that is. And then from this time over, what happens?
It's negative.
Constant velocity.
So that is velocity versus time. And then acceleration versus time. What's my acceleration in this region right here?
Zero.
What about in this region?
Zero.
But we got this bit right here, where suddenly I've got this huge negative change in velocity in no time at all. So how would that show up here? It'd be a spike downwards. Now, if this indeed is straight up and down, which a sharp point right there would indicate, if that's straight up and down, then this would shoot down to negative infinity. Newton's third law, force equals mass times acceleration. So if my acceleration is infinitely large, the force is infinitely large, and that's what would kill you. You get into a chicken and egg argument about the force causes the acceleration or the acceleration causes the force. Well, the force causes the acceleration. But we can only withstand so much before we die. And I have all this written down about what our bodies can take.
It's not a ton. I remember reading this a couple of times, the force of gravity, because G's are acceleration greater than the force of gravity. I can't remember that. I agree. I think I've read a number somewhere.
So if you're experiencing 2 G's, you're experiencing a force that's twice your weight. It's as if your acceleration is twice normal acceleration. And so there's 2 things. One's the number of G's, and also how much time can you take it. Because I can take 2 G's, but I don't know if I can sustain that for a couple of minutes. 5 G's, I think I would pass out. I'm trying to remember from the chart. And Air Force pilots, because they have to be able to do really sharp turns and they're going incredibly fast, there's a lot of big change in velocity here. They have special suits to try to keep them from passing out. Because as you're zooming down like that, inertia, things just want to keep going straight, and so your blood tends to leave your head towards your feet. So they have compression suits to keep the blood from all pooling down at your feet. All right, so Emily, you started off, I went off on a tangent there, sorry about that. Do you want more, or is this enough to get you going, or tell me what's going on?
I think that's good.
Okay.
Yeah. So with these like graphs, like with the lines, like, do we just like put numbers where the lines are?
No, you can just
Does it have
sketch
to-
it out. I mean, for instance,
Exactly.
that first one, it says you're heading towards the origin for 5 seconds, and then you stand still.
Yeah, I was mostly asking like if it has to be like exact with like the, you know how to explain this, like should I just do 0 and then 1, 2, 3, like write them?
You don't even have to put any numbers down.
Okay.
It just
Just
zero is
like
already
graph.
identified, so you can identify what's positive and negative.
Yeah. Okay.
Other than that first one. Zero there. Something like that. Numbers are not necessary.
Okay. Thank you. I just wanted to.
That the key in terms of my terminology is when I write sketch, that means you can get away with the numbers.
Okay. Thanks.
talking about Newton's second law. And I've written Newton's second law on the board. And anybody just want to blurt out, show off that you know what Newton's second law is?
Acceleration is caused by net force.
Keep going. They're mathematical formulas.
Force equals mass times acceleration.
Yep. Newton's second law, or as I'll abbreviate it, N2L. I consider this the most important equation in all of physics. Now, this is the simply way it is written. This F right here represents the total force. Even though it doesn't say F with a subscript of net or total, or that there's no summation sign, it's understood that force here is the total force. This is the mass. Upon which the total force is applied. And that is the acceleration. It's how the velocity changes. So early on, I think in chapter 2, when I talked about equilibrium, and I said if the force is 0, that also means acceleration is 0, which also means the change in velocity is 0. If the force is 0, acceleration is 0. Assuming you're dealing with a mass, which in this course we will. And acceleration is the change in velocity over the change in time. So if acceleration is 0, my change in velocity is 0. So total force is equal to 0. Means acceleration is equal to 0, which means change in velocity is equal to 0. And the vector symbol over the 0 is just a math thing. It's part of the mild OCDs. So if one of these is true, the other two are true.
What is next to the 0 on acceleration?
This, meters per second squared. Other units, 0, so there are lots of units, as long as it's some distance unit divided by some time unit, 2 time units, it works. Parsecs per millennium centuries. I don't know why you do that, but why not? So what we're going to do here is we're going to actually see if this works. Or it's a physics demonstration, so we're going to hope that it works. So first off, we need to figure out the mass. So I have a cart right here. We're going to just put it on the triple beam balance. Some people, when they have measured this, or measured the mass of it, they put it like this. Just put it upside down, it doesn't roll as well. It's going to be somewhere around 500 grams, just because I've done this enough. And it looks like it's just a little bit more than 500. Looks like more than 510. And less than 520. Now the triple beam balance, the back side is 10 grams in multiples of 10. The middle one is multiples of 100, and the one that's closest here, it's marked off in terms of 1 grams, but then it also has 1/10 of a gram. So on a lab, for example, if I say find the mass, and then I put plus or minus 0.1 grams, that's saying that I want you to get down to that level of precision. So this one right here, I've got 10, 500, so 510, a little less than 511, so 510.74. Now, I took it one more place than was required, so I only needed to take it to the 10th place, but I took it to the 100th place. That's fine, just don't go less. Now, suppose it come out to 510 exactly. And I had this here, and you write down 510.
Would you write 0.0?
Yes, you would. Because this says you rounded off to the nearest 10. You need to follow how far I want you to take it. So if it comes out to something even, please fill the rest in with zeros in the right spot. Now, this track is actually incredibly level. I'm not used to that, but I have a super pulley over here. Super pulleys have two advantages. One, there's not a whole lot of mass there, so we can ignore it. And also, I've spun it, and it'll keep spinning for quite a while. Unlike some of the cheaper ones. If you're doing a lab with pulleys, and you will be, if you're doing a lab with pulleys, please make sure you don't grab the crappy ones unless they're out of the good ones. Now, people with better fine motor skills can thread the string through this tiny little hole right here, and most people do. I don't have that skill, so I just added a little twist tie here. That mass is the cart with the twist tie, because they're going together now. And then I need string. That will go from, yep, that should be enough string. Now, some of the carts that we have plungers attached to it. You really don't want to have the plunger pointed towards the sensor that is going to come into play in just a moment. All right, that seems to be holding pretty well. All right, so I have a mass here, and I'm going to have it accelerate, so I need another mass to actually accelerate it. So I grab a mass hanger. I could have done a hooked mass as well, but I went for the mass hanger. The new show on Fox. I always assume I can do this much faster than I actually can. One of these days I'm gonna take that into account. All right. Now, the mass hanger has 50 grams. What I would really do in an official lab is I would find the mass of this. Matter of fact, not here. It should be somewhere around 50 grams. Looks like it's just shy of 50 grams. It's just a little bit more than 50 grams. And close enough for what we're doing right now. And so this is 50.4 grams. So this is the hanger. ER. AR is like a plane hanger, right? ER is things that hang. So, So, I'm gonna attach the mass hanger to it. Now I wanna hold this still, because I don't want it to go before I'm ready. I don't want the mass hanger to actually touch the pulley, I want it to be hanging somewhat freely. And then I let go, and I also want to stop this before it hits the pulley. And once that touches the ground, then it's no longer accelerating it, so I really need to stop recording however I'm going to do it when it gets to the ground. So the question is, what was that acceleration? And we calculated what it's supposed to be. What was it experimentally? Or how would you find it?
The change in distance over the change of time that it took for it to get to the floor.
If we did change in distance over change in time, that would tell us average velocity. If I know, what was the initial velocity?
Wouldn't have been 0?
Yeah. All right, so my initial velocity is 0. My average velocity is just distance over time. So let's write some of this stuff down. All right, so average velocity, displacement over time. Now I'm only going in one direction, so average speed is just the magnitude of my average velocity. I know my initial velocity is 0 meters per second. It's a one-dimensional problem, so I'll just say that to the right is positive.